Let's translate the math and plots into clear physical language for the multiverse, retrocausal idea. We will map the pieces one to one so we can see exactly what the equations allow, what they don't, and what would be required to make a real future branch influences present effect. 1. What the math actually shows. Simple statement. The master equation and memory kernel mathematics that we used shows when a previously decohered off-diagonal density matrix element, called ρ01 as a function of time, can revive, or recohere. The physical mechanism is the following. The environment stores phase and correlation information, and later feeds that information back coherently to the system. Mathematically, this behavior is described by a non-Markovian memory kernel, called k as a function of time minus time prime, which returns amplitude to the quantity ρ01. The conclusion is that, in principle, under ordinary unitary quantum mechanics, branches of the wave function that appear to be separate can re-interfere if the environment preserves and later returns the necessary correlations. No modification of the Schrödinger equation is required for this effect to occur. 2. How this maps onto the many worlds picture. In many worlds, MWI, a branching event corresponds to the global wave function becoming, very nearly, a sum of effectively non-interacting branches. Decoherence makes the environment states associated to those branches effectively orthogonal, so branches don't interfere. Recoherence equals partial rejoining of branches. If the environment does not irreversibly disperse correlations, branch states can regain overlap and interfere again. So MWI already allows branches aren't permanently separate in principle. Important caveat. MW branching is approximate and effectively irreversible for macroscopic systems because the environment has so many degrees of freedom. Information becomes effectively lost for practical timescales. So although mathematically possible, recoherence of macroscopic branches is astronomically improbable.